We've already discussed definite integrals. Today we're going to discuss indefinite integrals. And the difference is that a definite integral that we've talked about so far has limits of integration. It has endpoints, upper and a lower limit. Where an indefinite integral is for a family of functions for any limit requirement. You notice no a and b value, where a definite has an a and b value. So, since we don't know the upper or lower limit, we have to have that plus c, just like we had at the end of chapter 3 when we did integrals, or antiderivatives, I'm sorry. So, integral of x squared dx, anti-derived, add your plus c, and you're done. Secant squared, anti-derived, add your plus c, and that works because the derivative of tangent x plus c is equal to secant squared x. Now, for these anti-derived, don't forget your plus c. For a problem like number 2, where we don't really know a function whose derivative is cosine over sine squared x, we might have to use some of our trig identity knowledge. I'm going to break this up a little bit. It's going to require you thinking outside the box. And you're going to see that this is actually equal to cotangent theta cosecant theta. We do know a function whose antiderivative is cotangent cosecant, and it is negative cosecant theta plus c for the antiderivative. Now, let's try one more. Use FTC2. Anti-derived. Got to make sure we go from 0 to 3, so we get 1/4 times 3 to the 4th minus 3 times 3 squared minus, when we plug 0 in, we just get a 0. So, 81/4 minus 27 is 81/4 minus 108/4, which gives us negative 27/4, or negative 6.75. And check that on your calculator to make sure you're right. If you have questions on how to do an integral on your calculator, you should be asking me tomorrow. Ask me as soon as you possibly can after a question comes to mind so you don't go on confused.